Section 1.5, Topic 3, Significant Figures. Suppose you determine the mass of a dime on a balance capable of measuring to the nearest 10,000th of a gram. You could report the mass as 2.2405 plus or minus 1/10,000th of a gram. The plus or minus notation, read plus or minus, expresses the magnitude of the uncertainty of your measurement. In much scientific work, we drop the plus or minus notation with the understanding that there's always some uncertainty in the last digit of measured quantity. That is, measured quantities are generally reported in such a way that only the last digit is uncertain. Figure 1.25 shows a thermometer with its liquid column between scale marks. We can read the certain digits from the scale and estimate its uncertain one. From the scale marks on the thermometer, we see that the liquid is between 25 Celsius and 30 degrees Celsius marks. We might estimate the temperature at 27 Celsius, being somewhat uncertain of the second digit of our measurement. All digits in a measured quantity, including the uncertain one, are called significant figures. A measured mass reported as 2.2 grams has two significant figures, whereas one reported as 2.2405 has five significant figures. The greater the number of significant figures, the greater is the certainty implied for measurement. When multiple measurements are made of a quantity, the results can be averaged and the number of significant figures estimated by using statistical methods. To determine the number of significant figures in a reported measurement, read the number from left to right, counting the digits starting with the first digit that's not zero. In any measurement that is properly reported, all non-zero digits are significant. Zeros, however, can be used either as part of the measured value or merely to locate the decimal point. Thus, zeros may not be significant, depending on how they appear in the number. The following guidelines describe the different situations involving zeros. Zeros between non-zero digits are always significant. 1,005 kilograms, 4 significant digits. 1.03 centimeters, 3 significant figures. Zeros at the beginning of a number are never significant. They merely indicate the position of the decimal point. 0.02 grams, 1 significant figure. 0.0026 centimeters, 2 significant figures. Zeros at the end of a number are significant if the number contains a decimal point. 0.0200 grams, 3 significant figures. 3.0 centimeters, 2 significant figures. A problem arises when a number ends with zeros but contains no decimal point. In such cases, it's normally assumed that the zeros are not significant. Exponential notation can be used to clearly indicate whether zeros at the end of a number are significant. For example, the mass of 10,300 grams can be written in exponential notation showing 3, 4, or 5 significant digits depending upon how the measurement was obtained. In these numbers, all the zeros to the right of the decimal point are significant, rules 1 and 3. The exponential term does not add the number of significant digits.